Okay, yeah, let's start. So, long title, so who's this guy? So, I'm a software developer, like all of you, right? So, I like writing software. That's what I do most of my time. I'm not the expert on AWS Lambda and Azure Functions. Actually, I don't think you can get an expert in AWS Lambda and Azure Functions. I merely use that as a tool to solve business problems, right? And I only use the bits that I need to solve the business problems, right? So there's a lot more that I think it's going to take longer than an hour to cover everything around AWS Lambda. So what I want to kind of take you through is my experience with working with these two, and why kind of I work with these two in a way. I mainly work in teams, so I can't take credit for any of these either. So this is basically, if you like it, credit goes to my team. And in fact, even the demo here, I had 3 iterations of it. All credit goes to my son. He was the product manager. I just wrote the little code around it, right? So if it's bad, it's my fault, right? If it's good, it's the team, right? So what do? I have 2 jobs, actually. I write software for big enterprises who kind of want to move things to Azure and AWS, primarily AWS. And that's what I do, 9 to 5. And I'm also, I've got started with a couple of friends. We've kind of created a platform for selling wine. The little wine merchants you kind of never hear about. We kind of give them a platform to sell their wines. It's not the wines you buy at Tesco or Sainsbury's. These are like, really nice wines. And who doesn't like wine? So, I mean, I got into that because I just like wine, right? And we've got a BizSpark kind of in that program. So we use Azure. And we are 90% Azure, 5% Amazon. But on the daily basis, I work with Amazon. And which is why I'm kind of doing this, because to actually get to where I am with these technologies is not been smooth, right? So, the documentation tells you one thing, and when you start working with these things in production, it's a different story. Whether it's a good choice, actually, I wouldn't use anything else for the problems they try to solve. And I'll tell you why, right? So, why? I'll start with why. I mean, who went to Ian's talk yesterday from the team? Yeah? Yeah. So, Ian did a better job than I'm going to do of this. I'm going to take you, and I would recommend, if that's recorded, watch that. That's, a brilliant talk. I'm going to go through my kind of view of things. I've been a developer for a couple of years, and I started with this, but this is something I drew on a piece of paper with a friend once. I'd kind of taken the DDD pill, domain-driven design, and I was selling DDD to everybody. Domain, we need to write. I was actually doing DDD, right? But I was preaching it, and I kind of learned what DDD actually means over time. But I remember sitting with him, and I was like saying, you got DDD is cool, and he was going, no, F#. I'm started doing F#. And it's a couple of years ago, no one had heard of F#. I said, why would you use F#? And we started talking about this, and in domain-driven design, you've got something what you call the core domain. That core domain is a bit that differentiates you from your competitors. It's the code that you write that has no dependencies. It's pure C#, pure business-like, right? So this is your business core domain that you, I'll show you on the next page. You basically there's a couple of patterns to make sure that piece of code stays pure. That describes your domain. Right? And then you got all the other bits and pieces around it that, infrastructure services, that, do other things like, integrate with, repositories, the old school kind of patterns, right? So we drew this, and he kind of said, what, F# would fit well in the core domain, because actually it describes your domain in a more natural way. And actually we sat around and he goes, actually, it does. You can read F# and it maps directly to your domain. But the rest of it doesn't need to be in F#. I mean, that's not what your customers pay you money for. They pay you money mainly for that bit there, because that bit is the bit that differentiates you from your competitors, right? this book is amazing, all right? So if you get a chance, read it. The only thing I would say is it's back to front, right? So all the cool stuff is at the end, and I would start reading it from kind of chapter 14 and come back. So this is directly from his book, right? The core domain is the domain which makes your business unique and gives you an advantage over your competitors, right? And you got the generic subdomain. It's still important, right? But there's a chance you'll find another solution, and that's what companies do. This is the bit that open source, because it's not something that is interesting for them as a business. It solves the problem, right? It's good to open source, say, get developers working, or choose something that's there and contribute to that in an open source way. Very few people actually open source that middle bit, right? And because that is where you make your money, and that's where you add value. But to be honest, in this book, he goes, put all your developers to write code on the core domain. The best developers you have, put them on the core domain. But what happens in today's world, right? You'll find all the developers are working on these bits here. They're working, solving infrastructure problems. They're solving like bits that don't really solve the business problem, right? And that's what happens in companies. And his book talks to you about not doing that. Put your developers where the money is, in a way, best developers, and add value there. And people then wonder why you don't get the best software. And the problem is that book talks about that bit there needs you to talk to customers, and that's a challenge as well, right? So keeping that in mind, that kind of was the first time I actually thought about like domain-driven design. What's important? What code should I be writing? Yeah, should I be spending more time doing that, right? And then back to F# and functional programming. Yeah, functional programming, is based on kind of data coming in, data coming out. Ian mentioned this yesterday. It was adapters and was it posts and adapters, and AWS Lambda functions are like that to me, right? It's like almost functional programming at kind of the higher level, right? So you write a couple of functions and you tie them up together using bits that you really care about. What's in those functions, what you write, is more important to you as a business. That makes sense? And the bits that you don't write, you let someone else write them, right? You don't care about. So to really appreciate, I think you've got to go through this journey. If you haven't built monoliths, haven't kind of worked with infrastructure as a service and trying to write, Terraform solves bits and pieces these days, right? CloudFormation, writing Azure resource templates to basically just spin up a machine, managing AMIs, right? That's a lot of pain you have to go through to get your code to actually work in the cloud, right? And I think you've got to go through this, setting up deployment type pipeline. How do I get my code on that machine that I've kind of spun up? It's immutable, right? But how do I get it on that machine and run it? I've got to solve that. And then I've got to monitor dashboards to figure out, what happened with the infrastructure. And then I have to worry about costs. Why are my costs? I need 3 machines of each because I need HA, right? And then you fall into this whole problem of like, you got like a base set of machines, and you've got to keep it all running, right? That's where you spend your time, most of the time actually. However, you may get function fever after playing with AWS, and the whole kind of Lambda. AWS Lambda and Azure Functions do not solve every type of problem, right? So in this, even though I'm going to be talking about serverless in this session, it doesn't solve everything. So Barco.com, that site, is not really a serverless kind of, it's an e-commerce platform. We need server-side rendering, progressive enhancement. There's no way, I believe, at this point in time, I'll be moving that to serverless in a way. But everything behind it is serverless, right? So let's talk about how, right? So I'm gonna use something called a serverless framework. So AWS Lambda is really good. This is where Microsoft, I think, are slightly better than AWS in a way. They give you tools. Microsoft's very good at giving Visual Studio. AWS give you lots of raw bits, and then someone else kind of adds the bits together to make it gel together. So what I'm going to do is I will give you a hello world demo, and I'm not doing this. I'm trying to do this demo to show you something else, actually, in a way. So I'm going to use serverless. So I've already installed serverless. I'm going to do serverless create and stop there. Let's see what that supports. So I can actually write serverless applications in any of these languages. So I'm going to choose Node.js because it'll be quick, right? And I'm going to, that's -f, and minus -t, -p, quick, was supposed to be quick. And that will basically generate a template for me. If I look in this directory, I have 2 files. Oh. And I have something called a serverless YAML that just describes. I'll go through this later on. This is not the point of this demo. I just want to give you a quick taster. That tells me, I'm going to run AWS, and it has some bits that I can actually change, and it's got one function called the hello. If I look at the hello handler, that is my function. I'm going to change it slightly. Console log quick. Okay. And I can now deploy this. So if I do serverless deploy, too much coffee. So that is actually deploying my code in AWS. Let's look at what's happening. Where is it? I had this all set up. It's back here. So what's happening is if I go to the Lambda screen, it's actually creating a stack, CloudFormation. Why do Lambdas do demos go? So quick.dev, and as part of that, I get a Lambda, right? Which is called quick.dev, NDC. It's not yet created. Come on, wakey. Okay, we should see a new Lambda in there. I've kind of preset a demo here. I'll go through in more detail. But while that comes up, and it should be quicker than that, the joy of demos. Okay, we'll come back. Let's go back to our presentation. I'll come back to this, right? So when that comes back, right, we're going to play with it a bit. But the point of this demo was that actually I've got in 10 lines of code all that for free. So my hello world is the most scalable hello world ever, right? Well, in this world. I've got high availability across 3 availability zones. I can have 100 concurrent requests, right, to that hello world app. It's a soft limit. I've got free logging. I'll show you. I've got monitoring and alerting, right? I've got DDoS protection. No one can hack me, right? Well, they can, but it'd be, they have to get past Amazon. I've got authentication for free. I've got configuration through environment variables. And that was supposed to be really quick, but, when it comes to a demo, things do go slow. I don't know why. It's something. Oh, so that's it. It's deployed, right? So it's kind of deploy that function. If I go into the console here, refresh, I should see quick dev hello, right? And that's my code there, right? I can configure it, give it more memory, dead letter queue. If it fails, I can configure that. So VPC, I can add triggers. So I can say, and talk about this a bit more. I want any of these to call it, if based on how they work, and I'll go into more detail around that. And I've got monitoring, out of the box, right? So also I have logging. So I'm going to do one thing. So I'm going to call this invoke, right? -f hello, right? So that calls my Lambda and returns, that runs in AWS and returns or the response that it was configured to do it. If I do invoke local, this invokes the Lambda in memory, not in Amazon, and basically I can test it locally. So that is my hello. And if I do serverless logs -f hello, that will show me the CloudWatch logs as part of that deployment. So I get all that for free. If I do serverless, I can roll back. So I can find out more information, query. I can deploy list. If I had multiple versions, timestamps them, right? And I can roll back from the command line. So it's all one-liners, right? So I've actually got almost like a deployment pipeline. Well, it's a bit of automation. I can deploy that. That's not the exciting part of my presentation, by the way. That was just to show you that I get all this with 10 lines of code, right? Azure Resource Manager is different. So functions are different. So this is, I think this is kind of a, when you set this up, it's the first clue as to what the differences are. And it's not bad, it's just different. Azure Resource Manager is more about having an application, and within the application, functions run. Yeah. So whereas the Lambda, AWS Lambda, is completely free, you know, it's just single, you know, no dependencies, that's so on. Azure actually has a concept of an application with functions in it, right? So you've got to basically create the application resource, use the application resource manager, and deploy that. So what the application resource manager does, so all this code, by the way, the demos and everything here is on GitHub. I'll send this around. It looks like that, right? It's like a bit like CloudFormation in JSON, right? So some kind of you know, parameters, some resources. There's my storage. This is my kind of application plan. I've chosen dynamic. Dynamic means spin off a container when I need it, right? And then, you know, I've got my function and all its configuration. I can deploy this via PowerShell, but what I've done is I've given you a little link here that gets you to log into Azure. And once you're in Azure, you can fill in the blanks, and it will create you an app template. Now, after you create this, there's a bit of PowerShell to run. And since I have an hour, right, I mean, we can do this. Like, actually, you know what? That's the whole point of the demo. Let's look at something that's created. So that template is going to create you some storage for the functions, storage for what I need, and your functions, right? In here, your function app lives. So you can see that your app here, right, has a set of functions when it comes up. Thank you. I feel like as if the wired connection is slower than the wireless. Yeah, so the function app settings, as you can see, are for the whole app, right? So when I specify environment variables, anything, that's for the whole app and across all the functions. Whereas in AWS Lambda, it is per Lambda. It lives on its own, right? That's the big major difference. It's not bad. I think they're good points to both. And yeah, we'll go through a bit more in detail as we go through my demo. So there are two models. You've got the consumption dynamic, which is equivalent to AWS Lambda, works exactly the same. And you've got the classic model where, you know, things just run. They're like almost EC2 containers that, you know, spin up, and they run, you can use them for long-running tasks. You can't do that in Lambda at the moment, right? So Lambda only runs maximum 5 minutes, right? So I thought what I'd do, and this is the idea I had of it. I wrote this demo 3 times at 3 different stories. So I came up with this story, and this is more realistic. This is a problem we have on Baco. So if I go to baco.com, By the way, we drink more wine than actually sell. So, so if you go to the site, you'll see that we miss. It's not these are not missing images. They're really bad, right? You look at that bottle of wine. That's £5,100, right? And look at the image, right? And the details. There's not much there, and it's mainly because, right, we rely on our merchants to upload the images. So they're not good quality. Sometimes they don't contain a bottle of wine. They actually contain something. It's interesting, right? And the images do not always contain the bottle of wine being sold, which is even worse. I think it's just a deliberate mistake in a way. Good images can be overwritten. So if we get data from one merchant, that wine, and it's a good image, the next time we go to a different merchant, he can upload an image and it overwrites the good one, right? So we get images like that, which has a background. It's not very nice. I mean, that's actually not too bad, right? So I thought, let's kind of solve this, right? It's a real problem, and I think Lambda's pretty good for this. And I'm actually going to use Lambda and Azure to solve this because Baco is in Azure, and mainly because I wanted to give you some code that shows both sides of the thing. So there's a new service, Amazon Recognition, that looks at a picture and tells you with some certainty what's in that picture. It's really cheap, it's $1 for a million images. We don't have that many, right? And $80, dollars. I mean, I could write something from scratch, but it's never going to be as good as Amazon Prime. This is what Amazon Prime photos kind of use behind the scenes. Why can't I just use that, right? So I thought, let me pick that up, right, and call that. But that will solve the problem where, the image doesn't contain a wine bottle of wine, right? It might be red wine, white wine. This should tell me. The other problem I have is I don't know whether it's the right wine. So there is this Microsoft Cognitive Services that can read labels of or text of images. I thought, and wine bottles, if you notice, the text is never the same. I mean, the bottle is the same. Every wine bottle looks very similar, but the label is never the same. And the text is always sometimes vertical, and I need to solve that. And it could be in any language. And this thing works really well. So they've got a set of engineers whose full-time job is to write that. And it's quite cheap, $1.50, 5,000 free calls. I don't need more than that, so I can get it for free. I can get both for free. On a free tier, I don't have to pay for anything. That, I don't have to pay for anything for what I need. So it could work like that. So we have a merchant app. The merchant uploads his code to something, storage, somehow through a web application. We could poll, or we could send a message to something that picks it up, goes to Amazon Recognition, right? Finds out if it's a wine bottle, and says, okay, yeah, fine. If it's a wine bottle, I know it's a wine bottle. Maybe I can get the next bit to read what it is. What wine is it? So the next thing picks it up, goes to Cognitive Services, and says, yeah, okay, fine. I read the label. It is the wine that I think it is, and I'm going to forward it on. Through the first step, I know the quality of that image. I also know it's a bottle. Second step tells me what wine it is. And then the third bit can take it and forward it to Baco.com, which is in Azure. And also notify me via Slack. So I thought, yeah, let me try and solve that. So I thought, I'll pick Node.js, just because I kind of I feel, I'm more productive in Node.js these days. I've kind of adopted this functional style of JavaScript. It's quite nice. It's easy. It's quick to test. You don't need fancy editors. So I picked Node.js. C# is also supported. I don't want to write Java. So this is what a traditional solution would look like. So I thought, yeah, I can have a web server that I can post stuff to, writes to some storage. I'll choose S3. I'll be nice and send a message to a queue, right? And then that guy there, the worker, can pull and do all those bits, right? It's not very microservices, right? So basically that can just pull and do the rest of it. So this is kind of a nice, easy solution for a startup. That's fine. But I thought, you know what, let's try microservices within that model. But if you look at that, right, even this, I need an auto-scaling group, 3 machines, auto-scaling group of single machine. Yeah, this is good practice from Amazon, right? I need to set that up. I need machines, right? I need to put the code on there. I need logging, monitoring, CI, you know, and I need to manage the AMIs. And if I can choose Beanstalk, that's another solution, but that's serverless again, right? So this is kind of the more traditional way, right? The serverless side, this model, Amazon recognition, yeah, split. Each piece does its own bit, right, and then forwards it on. I have queues between each one that manage, you know, I can pull, look for work, and then do the next bit. That works quite well. That can work. But the whole point of this is to serverless, and then I need to consider all that, right? You know, if I was doing it not for a startup, right? Log services, log shipping, agents. I've got to put, you know, agents on the boxes to ship the logs, monitoring services, code deploy, deployment slots. I've got to worry about that on Azure. Security authentication, I need identity server maybe. Yeah, okay, fine, I'll do that, right? But I thought the whole idea is to use serverless. So this is, I didn't come up with this by actually, I started outside in, right, with this model. And I kind of ended up with this. So the journey to get to this is not, you know, one step. It's a couple of iterations, right? So my first problem is to create a website. So I took a bit of, I decided to choose single page app, host it on S3. That's enough for me. I don't really need a web server, right? So it's a static site. The JavaScript runs in the browser. I'll just basically host it on S3. Build it, host it, right? Then I need S3 to upload my images to. But to upload to S3, I can open it up, but I want to be a bit more secure. So what I'll do, I'll write a little service that, can I walk? Yeah. That all it does, right, is that guy there, it goes through S3 and creates a signed URL that allows me to upload that image within a certain time, right? So all it's going to do is, I'm going to call it, it's going to return a URL that allows me to upload the image, that specific image, in a secure way. Although that's good, that's a good pattern. And that's a serverless pattern to use, by the way, to upload things. I thought, let me do a bit of bonus and write a get that goes through S3 and returns a list so that, you know, the merchant's happy, he can see what he's uploaded. That's a bonus. Then this is where it gets exciting, right? It's when I upload the image to S3, I don't have to write anything that polls S3 or does anything with S3. I can write a Lambda that gets triggered when that image is written to S3. So when I write the image to S3, that Lambda gets called. And that Lambda, its job is to go to Amazon recognition, right, and ask about the labels. And if it's a validate label, if it's a bottle, it's going to send a message to SNS, right? Here's a valid image. It's going to get all the bits it needs, the labels. Is it wine bottle? Is it red wine? Is it white wine? And it's going to tag the S3, right? So object. So I don't need a database. In fact, I thought, I'm going to try and defer using a database. So what I'm going to do is to actually add the data, I'll just add the data to the metadata of the object. So I've got a tagger that adds data to S3. And I've got another subscriber to the publish subscribe that says if it's a bottle, yeah, forward it to Azure. So that's going to go to barcode.com, right? And on barcode.com, in Azure, I've got Azure Functions that do the same thing. So to upload that image, I've got the same pattern. I've got to get a signed URL from the blob container. I can open it up, but it's not secure. So I'll ask Azure, give me a nice signed URL. Then I'm going to upload get my little Lambda, AWS Lambda, to write to the blob container, right, using that signed URL. So it's all HTTP, right? And that is going to trigger off my Azure function to go to Cognito, right, and then find out what's on that label, right? So let's look at the code. So I apologize, right? I mean, in advance, like you know, coding-wise, right? You know, I try my best, right? So let's look at some code. Actually, you know what? GitHub's much better to look at code, right? So let's look at. I thought I had GitHub open. Oh yeah, because I went to Azure. It's me 20 years ago. Right, so this is the code I've ended up with. So under Merchants is the Merchant app. I have a website. It's React-based, right? There's nothing much in there. All it does is, and I'll show you what it does. It just creates a list and shows what's in S3 and the tags on those objects. The exciting bit comes in here. I've got the upload, and in the uploads, if I go to serverless.yaml, what I've done in here is kind of said what permissions I need to give that Lambda, right? I also have two functions, right? That's signed URL creator, and I have a list uploads Lambda. All it is an HTTP, listens to HTTP event, right? And runs some code and returns some body, some JSON. The other one is another HTTP endpoint, right? And returns some other JSON that talks to S3, right? So let's look at that function, right? We won't go through every function, right? By the way, there's not many. So signed URL generator, all that does is that's how much code there is, right? All that's going to do is talk to S3, give me your URL, right? I don't have to write a lot of HTTP, translation or anything. That's all defined within templates or within, the translation layer. I can just return data, right? And you'll see more of that through my presentation. This is a bit more involved. This does a bit more because it gets the tags out. So it gets the list of objects. And for each one, I can't do it in one call. It returns the tags on it and then decorates that object and returns that. So that's my list, right? So that's uploads. Let's look at one more, which is within the scanner. And in the scanner, I have three handlers, right? So one scans the image, one tags the image, and the other one scans the label, which all it does is forwards it to Azure, which is the cognitive services, right? Actually, I'm going to drive it through here. So if you look at one of these functions, let's look at the one that actually goes to recognition. That's it. All I do for recognition is tell it where the image is in the bucket, and I call that. That's all the code I have in each Lambda. There's only like 20 lines. I mean, the less code you write, the more code you write, the more bugs you're going to write. There's not many bugs you can put in that code there, right? You might find some, by the way, but so there's not a lot. And if I look at the Azure side of it, right? So Azure is a bit tricky because Azure enforces a folder structure on you, right? So when I go in, I need all my functions at the top. So I've got the create sign blob URI, right? And that is very similar to the AWS one, right? So let's look at that, okay? So the handler is that. All it does is, returns data that comes from this guy here. And what does this code look like? That's it, 20 lines of code. Blob service, give me something that returns. I don't have to write anything that translates anything. All the translation is done in the JSON file. All I say is, this is the HTTP trigger in, right? Out. I'm going to return some console out or return some object. That's your function will convert that into a HTTP response. And that's how functions work. It doesn't matter. I mean, like, in terms of, I can write something today that listens to an SNS event, right? And actually, that might work for SQS. No, it won't work for SQS. There's no problem there. Work for Kinesis, right? And with a bit of changes, it can work for SQS, right? So, I can swap the triggers. Okay, so should we see this working? Right, so if I go into the code, all right, I was going to deploy this, but I'm going to run it, and then if we've got time, we'll deploy it into a different region, okay? The same code base. So NDC London, and I've got a gulp local task here. That all it does, it spins up the UI locally, but this is pointing to AWS. I should have cleared the bucket, actually. Let me do that. This is me testing before. So in the S3 bucket, you should already see a bottle there. Actually, yeah. I'm going to just clear the bucket. Right. Okay, let's go back to my demo, which I think is open up here. I'm going to refresh that. Shouldn't have anything. Okay, so this is, I'm a fantastic UI developer. I know the Aurelia guy is going to think, what's going on in here? I'm not a UI developer. So what I did was to plug in a kind of some HTML and something that allows me to upload some images. So I am going to find my images in here, and I have 3. I've got 2 wine bottles and a banana, right? So I'm going to upload the wine that you saw in the, and that's uploaded. That's querying S3. So that means actually it made itself to S3. If I refresh this, right, you can see it's in S3. Oh, I've got it running already in another window. Sorry, that's running. That's why you see that error. Okay, so if I go into my what happened there, right? So if I go into my merchants folder, I go into my uploads, right? And I run serverless. That's cat serverless. So I've got 2. Let's look at one of them, right? So serverless logs, right? -f signed URI creator. And I need to give it a stage. This is I've caused this pain on myself, actually, the stage. You don't really need that. And that shows me the logs, and it shows you that I created a signed URL. You can, monitoring is all set up, logging is all set up. So what happened there? So if I go to Slack, I see nothing. And this is the beauty of it all, right? So nothing in Slack, okay? So let's troubleshoot that, right? So we can go into Scanner, and we can see that cat serverless. So something's gone wrong, right? If I refresh this, I should see the tags on it. So yeah, so the tags are there. What that means is Amazon recognition kind of said that is a bottle, it's an alcohol, it's red wine. So that all that data comes from Amazon recognition. And it's now going to forward it to Azure. So something, and by the way, this is, I was expecting this, right? So in cat serverless, and I want to show you something else, right? So all that's going to do, I've got 3 lambdas in here, and one's the label scanner, and that forwards it. So let's do serverless logs -f labels, I can't type all of a sudden, and stage, yeah. Minus region or something. Give me logs. Okay, so that's said something like successfully received signed blob request. That's not what I wanted. Oh yeah, so yeah, it does. So it says successfully received signed blob request from Azure, and then successfully wrote to Azure Blob Storage. So what's happened on Azure? Oh, there it is. Actually, it just takes a bit of time. So this is one of the things I'm going to talk about. So lambdas go to sleep. It's called co-start, right? And so does Azure Functions. You've got to keep them awake, right? So what happened? I deployed, and that lambda went to sleep. There are tricks to keeping it awake. I'll talk more about that. But what's come back with? It's come back with a bottle of wine. I uploaded it. And it's actually read the text. So Wirken Gran Reserva is what that comes off that bottle, right? Let me upload another one. Since the lambda is warm, it should be quicker, right? So it should go off to recognition, and it gets the tags. And in Slack, I should see the new one, right? There you go. So Urbina, and it's read Rioja Urbina 2006. Let's try a banana. So I'm going to try banana, right? This is Amazon, right? So I'm just showing off what they've kind of done, right? So that should hit. Yeah, it tells me it's a banana fruit. And if I look at the logs, you'll see that what it does is it won't forward it on to Azure, right? So if a merchant uploads a banana, that's not what the logs should say. So that's the last log. Find a bottle. Failed to find a bottle, right? In banana.png, right? Yeah, so it works, right? And there's a couple of lessons here, right? So let me talk a bit more about AWS Lambda and kind of go deeper into this, right? So how much time do you have? Yeah. So AWS Lambdas are all about functions and events, right? You can have multiple event sources, like we saw SNS. We saw kind of HTTP event sources, right? That's API gateway in the mix. And you have two types. You have asynchronous and synchronous. And it's really important to understand the two, because the reason I was hoping the Azure one would fail is because my Lambda would have failed, right? And it didn't, unfortunately. It just took longer than it should. I put a real low timeout, and what I wanted to demonstrate is that if my Lambda failed, AWS would automatically retry. So AWS will retry 3 times. If it fails, I can say, put it into a dead letter queue. And I don't have to write that code either, right? So all the retry logic is built in. Writing into dead letter queue is built in, right? I don't have to write that. And I was hoping to show you that. Actually, it was really quick this time. Well, quickish. Synchronous, the HTTP, Cognito, they don't retry. So if it's an HTTP request, you get a response, there's no retries, that's it, done, right? And they behave differently as well. So if you've got streams, the mapping's different. And it's important to know this, because when you send a message through SNS and you get the message through to your system, it'll retry 3 times, right? Go to dead letter queue. When you have Kinesis is batch, it will retry for 24 hours. So you basically have to hammer your Lambda until it works. So you got to kind of almost code for the scenarios, right? You got to understand the different events. Azure Functions are Lambdas plus bindings, right? So you got functions, you got triggers, and bindings. You can actually, in Lambda, my first diagram, I talked about like codomain, and you don't have to write infrastructure code. In Lambda, you do, because your output is not magic, right? It's like you still have to write to S3. But within Azure, it has an input and output binding. I can say, I just output, and I want that output in my JSON to go to table storage. I don't have to write the code that says, put this JSON into table storage. I just define it. That means I can actually turn that output into anything else, right? So it's like, it's all defined within the JSON. Right? There's no limit to number of bindings, right? However, you can only have one event source in Azure. So each Azure functions can only talk to one trigger, can only have one trigger. In AWS Lambda, you can have multiple triggers on the same Lambda. So you can have Kinesis drive the same thing, S3, well, SNS drive the same thing as well. That was the structure we went through. Azure, all the code is in one place, and you can actually run this yourself, right? So all that should work. And if it doesn't, send me a message, and I'll or pull request. Let me know if it doesn't, definitely, because I'll make sure that this works. The demo's done. So what do I get for free? I get HA, I get multiple AZs, all that stuff will stay up, right? I get auto-scaling. If my barcode does really well, and we sell more wine than we drink, right? Then I'll have kind of, we will scale up, right? I get security, API keys. I can extend it to do OpenID Connect tokens. So, if I go to functions, let's say, I've done enough of Lambda. Let me give you a function demo. So I can go to Azure app start, and I can say configure authentic. Oh, thank you. Configure authentication, and basically I can choose from here Facebook, Google, Twitter, and any of these providers out of the box. It's simple as that. I mean, I don't have to write that code either. In AWS Lambda, you have to write an authorizer function. And actually, there's many templates for that as well. And actually, there's built-in ones for Cognito, right? Very similar to Lambda. So authentication is sorted. It's token-based authentication. Everything forces you towards doing things in the right way, in my opinion, right? Token-based authentication, little short-lived functions, logging, monitoring, alerting, deployment pipeline. You can actually connect that to Circle YAML, and there is one in there, and then basically automate that deployment. That'll just work. I get S3, durable storage. That's given, right? No AMIs to manage, no servers, no database to worry about, no complex code to maintain, right? I just rely on Amazon and Microsoft to write the code for me, right? And the retries are built in, right? And I can have delta queues, so I don't lose anything. And it's all pay as you go. I'm not going to talk about cost because everyone talks about cost in Lambda, right? It's not the main thing. It does kind of work. I mean, cost savings. The real cost savings from Lambda are not when it runs, it's when it's not running, if that makes sense. So if you got Lambda that, if my merchants are going to upload 10 images per day, I'm only going to get billed for the 10 images. I don't have something running for 24/7 that I'm getting billed for, right? That's the difference. But if now my merchants grow to such an extent that they're continuously uploading images, then I've got to rethink. Lambda might not be cheap, right? And you can see it in this table. The whole point of this table is like, if I have more and more requests coming in and longer and longer requests, it gets to a point where, EC2 might be cheaper, right? And minus the maintenance costs, but it might be that, Lambda's not the right solution for that. Okay. There's some cost calculators. I'm not going to go through here. You can put 1 million Lambda calls and it costs like 80 pence or something like that. It's ridiculous. So it is cheap, and so is functions. So I'm going to talk about testing a bit more. You got to treat your handlers. So if I show you one of those handlers again, apologies for going back and forth. There. So that's my code in the handler. Most of my code is not in the handler. My handler doesn't do very much. It's almost like a MVC controller, right? It translates kind of the handler world into kind of pure JavaScript world, and it's the same for C#. And it's recommended. I think you should actually code in that way, regardless. And portability. I could actually port these functions across Azure and AWS, right? That's the plus thing about that, is in terms of like they will just work with little work. And it goes back to my first diagram. Your customers don't care whether you're on AWS or Lambda. They're not going to say, I'm going to buy that bottle of wine because they're on Azure, right? It doesn't matter. And it doesn't matter if you're using the best of each either, right? So you can test everything in memory. So since everything's input-output, and if you in your Lambdas, if you are really going to integrate with AWS services, there's things you can spin up in memory. You can spin up Elasticsearch in memory and test that. To be honest, it's so cheap. I can just spin up another account and test everything in there. It doesn't cost anything. I mean, Lambda, you have to call it 1 million times. The millionth and one per month is going to cost you the money. The first 1 million is free, right? So why don't I just create a new account and test everything in there, right? It doesn't cost money. And I do need smoke tests. I mentioned that Lambdas go to sleep. It's a good idea to have a health check that checks the permissions. And at the same time, I can use Route 53 health checks to keep my Lambda awake. So that's one way of keeping Lambda almost good. So unit tests actually look like functional tests. Your deployment pipeline then looks like this. Build the pull request. Here you do the aslint. You do your unit tests. Some unit tests, you can do that. in the test, you can spin everything in memory, right? Test everything in memory, deploy to dev environment, that's cheap. Test things again, run acceptance tests on tests, and then promote to other environments. Yeah, so you can do a lot more in the pipeline in terms of in-memory tests. And Azure is a bit different. So Azure doesn't support deployments. Anyone who here works with Azure, by the way? Yeah, so Azure Functions don't do deployment slots. It doesn't exist at the moment. So one way to work with Azure is to actually have 2 service plans, right? So I created one beforehand. You can create another one. That points to your GitHub, a different branch, and you can actually deploy that branch, test everything, and then promote it to master. It's a bit weird. But I think they're going to solve it with deployment slots. It's coming. And since you have smaller functions, you can test everything in memory as well for Azure, right? Because the output bindings, input bindings have no knowledge of what it's bound to, right? Logging and monitoring in AWS Lambda. I showed you a kind of the hello world. I logged to console out, and it appeared in CloudWatch. Azure Functions, very similar. You have to log to the context. Very similar. You got CloudWatch for logging and monitoring on AWS Lambda, and you have App Insights on Azure Functions. This might work for a lot of people, but we tend to do this in production, where you've got CloudWatch. We have 2 plugins that are installed on the Logstash instances that grab CloudWatch logs and CloudWatch metrics and push them into Kibana. And there is Grafana integration built in for CloudWatch. We tend to use these because it gives us the flexibility to create dashboards. We've got stuff running on some of the servers that will work out, alerting, last alert. Functions as well. If you go to this URL from Azure, it shows you how you can push some of this into Elk as well. So all your Azure data can go into Elk, into one place. So you can monitor your whole AWS, Azure environment from one place. So, but these are servers, right? I mean, you can use the Elk kind of setup, or you got built in AWS. But you do need servers. And my point in this presentation is like Lambda, its functions solve some things for you. You still do need servers, and in those cases, they still run on servers. It's abstracted away, right? But you don't need as many servers. So you might decide to do identity server rather than use Cognito or any of that. It's a server, right? You still need to host it, but it's not as many. So tips on writing. Is that duplicated? Kind of, yeah. So treat your handler as you treat a controller. You need to save messages as stubs. So if you look in the repo, NDC London, you'll see a messages folder here, merchants, messages, and in here, I've got some messages I use to test. So these are very useful. So that's an S3 event that comes in, and I save these so I can replay them. So I can call serverless invoke local, invoke the Lambda locally on my box with the event as it would come from S3, and test my Lambda. I can attach a debugger to it. I can step through it. All that just works, right? Use of functional style. I mean, promises. Ideally, your Lambda should read quite nice. Shouldn't be a lot of code in there, right? I kind of prefer the promises, functional style, the maps, and what JavaScript gives you. That's ES6. Use F# if that's your preference. Keep dependencies to a minimum. So the more dependencies you include, the bigger the zip file gets, right? In Lambda, Azure has no zip file. So Azure, when you push a function, will build it on the box. Lambdas don't get built on the box, right? So there's a difference there. So, but there's a tax you pay. If Azure spins down your container, or Amazon spins down your container, it takes some time to spin it up again, right? And the more dependencies you have, the bigger it gets. So keep them small, and don't run big functions. You can run them on Azure. There's a plus, and they should just do one thing. All right? How much time do you have? 6 minutes, okay. And use messaging for cross-function communication. It's easy. It's not like you've got to introduce libraries to do that. It just works out of the box. Everything is stateless, and you should follow that model. You can't write anything to disk because you might not have it. You can't write anything to memory because you might not have it. So nothing is guaranteed. Your function gets invoked from scratch. It gets a message. It gets a message out, right? Write defensive code. 2 days ago, I was writing this code, and I did a deployment. And basically, while the function, Azure function was being deployed, I didn't handle the error really well, and I lost a message. So, and that was, I fixed that, but ideally, you don't want to be in that position either. And leverage dead letter poison queues. When you're doing something like SNS, definitely use that. If you're using Kinesis, right, or streams, or even in Azure, leverage your own dead letter queues. Don't let the retry logic on those things, because you don't have any control, kind of determine how things are going to be retried. And everything is via environment variables. If you look at the code base, I'm not going into this detail. Everything comes via environment variables into the functions, and then it's pushed to Lambda or Azure Functions. So I'm going to go through gotchas. There's a whole list here, right? These are all my learnings, and some just so the whole point of these is not to give you a whole list to tell you that these are the problems with lambdas I faced, and they might be unique with you, but it's also, some of these problems are quite nice in a way that it forces you to think in a way, right? So it forces you to write stateless functions. It forces you to write really small functions. It forces you to write functions that execute really quick. So, I've got solutions for these. We've kind of worked these out, but in most cases, like no support for queues. There's no queues support for AWS Lambda. You've got to wake up and trigger Lambda. There's a friend of mine, Yan Kui, who has written an article how you can write recursive Lambda, and that's another lesson. If you call a Lambda recursively for the whole month, calling itself, it costs like $2, right? It's unbelievable. It's still cheaper than an EC2 instance. API gateway support, certificate managers is missing. So everything in AWS, you get an SSL certificate automatically. Here, you've got to basically work it out. This is all coming, by the way. This is one thing about AWS and Azure Functions. Things change, right? And you might code for something now. Actually, it's supported going forwards. But there's always workarounds, right? There's deployment limits. It's a good thing. Tells you to clean things up. There's a max duration. 300 seconds. You can't set it more than that. If your Lambda's doing more than 5 minutes of work, you got to think why you're using a Lambda, right? Maybe you shouldn't be, right? There are timeout restrictions. If your code's still running and Lambda terminates it, right, it will still run in the background. Node is single-threaded, right, if it uses the same container. So you got to think about some of these things. Soft limits, you'll hit a lot of these, and I do. And these are there to protect you. I can send, and I've broken these. I've sent like 100 requests in parallel to Lambda, and the 101 fails. And actually, that's a protection in itself, because actually it's going to cost me money. I've got to think, why am I doing that, right? And then have a conversation with AWS. Actually, the turnaround to change this is like, 15, 20 minutes. Running out of VPC ENIs. This is when you're in a certain scenario where you're running the Lambda in a VPC. It can actually take up all your network interfaces, so you've got to think about how you construct your VPC to support Lambda, right? It can actually take over. If you scale out, it will take over all your IP addresses, and it won't cycle them because it freezes them. Your network interfaces are reserved, and there's no way of seeing that. Lambda's kind of black box, right? Authorizers are not easy to write. This is, if you're doing OpenID Connect or if you're doing some custom authentication, but there's a lot of examples. Usage plans, so you can actually say this API, I only support, throttling for this customer for 1,000, 2,000 for this customer. It's there, but it doesn't work that well. Retries may seem like magic. Sometimes it just retries forever, like Kinesis, right? And you've got to think about it. Use dead letter queues if you can, right? And actually, this is another limitation. You can only send 6 meg to a Lambda. Actually, that's another lesson. Why would you send more than that, right? The trick here is to write to S3 and then basically send it the path from S3 and do it that way. Azure Functions has similar things, right? There's no support for deployment swaps. There's no versioning. So when you push to Azure, there's no way to see versioning. The only way to actually roll back is to push again your latest code or something from Git. You've got to rely on Git for that. Whereas Lambda, you can roll back. It's Windows. It's not a problem if you're doing C#, F#, but with Node.js, when you've got NPM and you've got big directory paths, we've faced problems. But actually, that's a problem in Node.js and Windows, and it's been fixed in kind of some versions, not all versions. So you got to choose your Node.js version. The tools only work on Windows. I didn't do a demo of Azure. I was trying to keep this short. I'm almost there. So, and you got only 10 concurrent instances. That's instances, not instances of your functions, by the way. So there are limitations in Azure, but the scaling is, it can scale, right? So your source is deployed, not build artifacts in Azure. In Lambda, you push up the zip, your artifacts are deployed, and that's what runs. In Azure, it's your GitHub, it connects to, it pulls the code, builds it on the box, and then runs it, right? So here's the difference. And then enforces a folder structure, and you have to live with it, right? And there's one trigger per function. Okay, so there's some good things about it. In-memory tests, rely on it, right? There's lots of tools. You know, login and monitoring is out of the tool, but you know, there's options as well. That's it. So this is my last slide, by the way. So this is one of the lessons I kind of learned from this exercise. Focus on the domain, right? Be lean. In terms of delay, why do you need a database? So in terms of the last project I was on, the customer wanted something, you know, really quick to demo. I just put something on S3, gave them a demo in like a very short time, you know, to spin up a machine and put stuff there. It works really well in that scenario. And actually, that decision stuck. We've never actually taken that code out of S3 and put it on a machine. Actually, it works really well. And in Barco.com, we wanted to manage the categories of wines. And we thought, you know, we need a back-end application. We'll choose Aurelia. We'll write a server to manage it, right? And then, you know, we can, a database, we'll need all that. In the end, we put it into a Google Sheets, right? We put permissions around Google Sheets who can edit them, actually, and we got sync between Google Sheets and the website. That was it. That's our management app. It's Google Sheets, and it works. It just solves the problem. And we're delaying some of the decisions till later. We don't need a fancy solution. It just works. And actually, simple solutions actually work a lot better. Leverage cloud services. You know, in terms of, this is not, I mean, 20 years ago, I used to love writing that kind of code, you know, where, you know, you're writing infrastructure code. There's a point where you think, actually, you know, is it worth it? Why don't I just, you know, like identity server. You know, I've done a couple of talks on identity server. I love identity server. But actually, it's just quicker for me to pick Cognito or AD to solve that problem. And identity server to solve some problems, right? So I wouldn't jump to it. I would use it. But there are some scenarios I would choose this or that over. Yeah, so it's not all the same, right? Rely on event sources to invoke your code. Don't use a timer. Rely on that because these are more reliable. Actually, I've never had these fail on me, by the way. Use messaging queues between functions. Don't call functions from another function. You can do that, but don't do it. And build thick clients and thin stateless backends. Only in some cases. So for an e-commerce website, that doesn't work, right? E-commerce website, use progressive enhancement. And prefer async to sync. That's it. Questions? Thank you very much. Sorry, I think 4 minutes over. Sorry. Any questions around this? Yeah, sure.
Why shouldn't we be calling functions from other functions?
So you can, right? And we do that in some cases for CI tasks. So we don't use functions just to do kind of, you know, the app itself. But in CI, we have some bits that leverage AWS Lambda because we run things within a VPC. And we tend to call functions from a function. The recursive function is a quite neat idea where you can either wake up a Lambda every minute, right, to do something, or you can do something and call itself, right, which will do the next bit and call itself. And if you did that for a whole month, right, it's still cheaper than having a machine do it, right? So that's an example, right? Does that help? You can, yes. What I did locally with serverless local was actually calling the Lambda from my box directly. Not local, sorry, the serverless invoke minus the local. I'm calling the Lambda in AWS and returning. The interface between Lambda and anything else is still HTTP. And it's always a post. So even if you do a get to API gateway, it translates that to a post to Lambda, right? It still kind of spins it up, calls it, and then returns a get request. And now you can cache that and do all that. Yeah. Hey, Anthony?
So I have a question. This might be a bit conceptual. So say I have a web app for 5 controllers, 20 endpoints. Now I turn this into AWS Lambdas. I've got like 20 individual deployable pieces of code. Isn't this going to end up with I have a big pile of small things and I don't know how it all fits together. It's just a bucket of marbles.
Yes. So this is the case. So there is a scenario like this is why I mentioned like Bucker.com, the main website is an e-commerce website. It is. I wouldn't see that translating to the Lambda world because I want to progressively, provide that experience of progressively enhancing the website on the machine. So I want the template, right, the plain website, and make it richer on the box. So I want server-side templating. But for a back-end app where I manage things like I can leverage Aurelia, React to do the CRUD pieces, right? So there's not a lot there to do. There's only a certain set of API endpoints that manage certain things, right? It makes sense? I mean, in terms of like, you've got to think what the balance is, right? I wouldn't jump directly to API Gateway, Lambda.
I guess I'm asking more like, how do I work out what the app structure is when I've got nothing but a big part of small things?
Right, so in that case, right, they are, if you go onto AWS Lambda and the patterns, there is a Node.js Express. If your application is Node.js Express, you can move, there's a way of hosting Express and moving to AWS Lambda. C# world, not easy, right? But if you look at in the repo for C#, so API Gateway now supports C#. Now API Gateway can call your Owin pipeline. So you can host your C# code in a web API, and you can host it in API Gateway, right? So you can actually do both if you're using the Owin pipeline.